Run. Oh no, later.
Oh yeah, the fortune cookie.
Is this any of yours? It's important.
No. It was here on the floor just now. What is it?
A bridge.
Switch.
Looks like some electronic engineering.
Oh, okay, see ya.
I have to use that for
Some
my
mini
G
push
project.
button switch. It looks like the Arduino size button.
Spider, we call it spider. Forgot what's the name.
With her button.
She's still coming up later, but I don't think she will take that long. So I think we will still be on time.
Okay.
On time.
Like we'll still be able to start the super. Actually, we'll still be able
Yeah,
to
so
start
speed
super
run,
again.
speed run the Optile.
I don't think
I
it'll
don't think it will take that long.
Okay.
Is his slides like?
Yeah, he sent me the slide. Unless he was planning to do he's presenting on Zoom also, is it?
Huh, then just on your hand open his
Yeah,
slides.
okay.
Last time it was Evo. When I did.
Yeah, okay, yeah. So let me change the font thing.
Then he will just have your slides down. Nothing coming.
Duplicate, copy,
Speak slower, yeah.
duplicate.
When in doubt, ask some questions.
Yes. What?
Hello, testing.
Oh yes, yes, yes. Okay, what does it about picture?
Hey,
Oh, I just remember that. No,
the one is
你讲慢一点。
Hey, no tea.
there you are. Is the dog here?
oh no.
Oh, yeah.
No,
Where is the screen stuff?
they say it's mine.
Anybody want coin?
Wow.
Yes.
Yes.
I mean, you sure
Not today.
You guess again. You guess again.
Yeah, I'll send.
It's a participant. I was expecting. I was told it was at 7:30. No, never see. My satisfaction rating for this session is dropping. Oh, wow.
30 gram.
เขาวางไข่หม้อแต่ไม่กินเลย Yeah. I can hear excitement.
What? What?
I thought it's audio.
Oh yeah, why it's nothing showing up? Let me check. Is the stream up?
You're streaming on YouTube.
Yeah. Is it working? It says it's live. Okay, it seems to be live. Jesper, you got no speaker notes, right? Oh, I just realized the mic was on all the while. Okay, you can start. Yeah, it's not related. The mic is okay, so on the yeah, so you need to get them to. Okay, we'll be starting soon, so yes. Wait, let me check something. Where's the button gone? Oh, it's okay. Okay. Yeah. Check audio.
Testing. Can you hear me? Louder.
One sitting here.
Okay.
Some people say, some people say.
Can you hear me?
Louder.
Louder. Can you hear me?
Okay.
So hello everyone. Today I'll be talking about the ops highlight for today.
Wow. That's it.
Yeah, alright.
So first we will be looking at Mars. Mars is the only bright planet that is easy to see in February 2021. It is out at nightfall and evening throughout the month, and it will set at around midnight. The best time to view the planet is actually at opposition, which means that it's at the opposite side of the Sun from Earth. This happens every 2 years. Sorry, we're having some technical difficulties.
Is it on? Is it on? That one?
Wait, are you legit?
Anyway, no.
Okay, good.
Maybe don't on this one. Here the sound.
Yeah.
No, just now is the HDMI. That's outputting. Okay,
Let's just start again.
With the window. Okay. There it is. And
Can
let me try something now. There'll be some delay, but
delay?
okay. Okay, carry on.
Start again.
Yeah, okay.
So hello everyone. Today I'll be talking about the ops highlight for today. So first, Mars is the only bright planet that is easy to see in February 2021. It is out at nightfall and evening throughout the month, and it will set at around midnight. The best time to view the planet is actually at opposition, which means that it's at the opposite side of the Sun from Earth. This happens every 2 years, and the last time this occurred was in October 2020.
Yeah, okay.
So right now Mars is in the constellation Aries and is actually fading in brightness as it's shifting towards the sunset. But don't worry, Mars is still bright enough to be seen and it appears reddish. It just will not be as bright as it was in October 2020. So the next object you can see is Pleiades, also known as the Seven Sisters or M45. It is an open star cluster in the constellation Taurus and is composed of medium bright, hot and blue stars. It is quite close to Mars, so you can find it after looking at Mars by looking eastward of Mars. Okay. So another object you can see is of course Orion Nebula, also known as M42. It's one of the brightest emission nebula and is located in the constellation Orion. You should look something like this through a telescope as a whitish patch. As you can see, Orion Nebula is quite high up in the sky today at 9 p.m. and it will set at around 3 to 4 a.m. in the morning. So you should be able to see it and you have plenty of time to find and look at it. So the next is the moon. Most people think that the best time to view the moon is at full phase, but that's actually the worst time to look at it. This is because when the moon is at full phase, it would be very bright, as well as flat and one-dimensional in appearance. So the best time interval to view it is just at or just past the first quarter phase or at or just before the last quarter phase. This is because you will be able to see clearly the features on the moon more clearly due to the shadows cast on the moon. So right now the moon is at its last quarter phase and it will rise in Singapore at around 2 a.m. in the morning. So if you wish to see the moon and its features, you can wake up in the middle of the night to look at it.
Zoom in on that.
So finally, there will be a Venus-Saturn conjunction happening at around 6:30 a.m. tomorrow at the eastern horizon. But it will be quite hard to spot, even with binoculars, as the planets are aligned in a very bright twilight on these early February mornings. Nevertheless, if you wish to see the conjunction, you can try your luck tomorrow morning, but bear in mind the sun rises at about 7:15 a.m. So you don't really have much time to view the conjunction. So this is the end of the observational highlights for today. And we will now take a break and wait for the next talk on the solar system by Clarence Liu at 8 p.m.
Oh, I'm viewing Clarence Liu. What's going on? What's the other?
Can. But then the problem, I'm worried about the feedback. Yeah. Cause, it's extended. So what projector is the extended on your screen? Oh shit. Yeah.
So you can see my script.
Wait. So how's this gonna work?
Okay.
The live stream is from my com. Your extended screen is the projector.
But
I think I'll wait for you to send your shit to my computer. I think it's not really easy.
Okay. But how come like the extended screen is like different one? Yeah. Oh, yeah, pass this to you. The universe shut it down. Wait, don't read it. Fucking type you. What do you read? Never mind, you see later. the script. Oh, am I? Is it your screen now? So it doesn't matter.
No, it's still HTML on your side.
Your screen is it?
Whose screen is what?
Whose screen is being shown?
My screen is streaming to YouTube. Your extended screen is showing that YouTube.
To there.
So this screen is your screen.
Yes.
Ah, okay, never mind. Open my screen without seeing anything.
Why your screen looks
Because it's this one.
Hi, everyone. Hi, Nicholas. Yeah, you're muted at the moment.
Hi, Liu.
Hi. How's everything going over there?
Everything is just great. How's it going on your side?
Good, good. Yeah, as you can see, there's a sky full of stars behind me.
Ah, very nice. Hopefully you'll stay that way for tonight as well.
Yeah, I do hope so. So you guys will be heading out to do some observation later on?
Yep. Hopefully if the sky remains clear.
Right, that's good. So maybe we'll just take a few minutes before everything settles in.
Okay, sure, no problem.
Yeah, just give me a heads up when I guess everyone's settled on your side.
Okay, sure. Are you able to hear any feedback from my side?
No, I'm good.
No background noise, nothing?
Some background noise, but that's fine, that's fine.
Okay, apologies. It'll be less later on, yeah, during the
Okay,
actual
yeah.
thing.
No issue. Yeah, hi everyone who's there. I can't see you, but hi.
I'm not sure if it's a good idea that everyone will come connect and disconnect the HDMI.
No, is it cause I have the...
Try the volume.
Yeah.
Give me the HTML. Connect to my phone.
Okay.
Yeah, for those who are on Facebook or YouTube, yeah, we'll begin shortly. Just give us a moment.
But there's still no audio though.
Oh yeah, testing audio, testing 1, 2, 3.
Restart the...
Oh, restart that one, let's restart that one. The on button.
Volume testing 1, 2, 3.
Hi, for those just joining us on Facebook or YouTube, we're just taking a while waiting for our live audience over at the NUS with the NUS Astronomical Society.
Apologies, a bit of technical issues with the audio.
No problem.
Maybe another 1 or 2 minutes.
Sure, no problem. So currently we're facing some technical difficulties over at the NUS end. So just give about a few more minutes for them to settle the problem. And as well as for those who are on Facebook or YouTube, do take note if you have questions at any point during the session, please feel free to leave a comment, and myself or Julian from NUS will be taking your comments on YouTube. I'll be taking comments from Facebook. We'll answer your questions if any.
Okay, my side is good to go whenever you
All
are.
right. Great. So yeah, once again, for those who have just joined us, entered the LT, or you have just joined us on Facebook or YouTube, this is Clarence. And you're here with the Universe at KANG, so as well as the NUS Astronomical Society over at NUS. So so today we're actually going to talk about the solar system, and we're going to move on now. Okay, so I'm just going to say the golden phrase of this last 2 years, which is I'm going to change my share screen. And all right. So hi. So Nicholas, everyone can see the screen? Good.
Yep, everything is perfect.
Oh, good. Awesome. Okay. So yes, so today we're going to talk about the solar system. Not sure how many of you are familiar what exactly is the solar system. But hopefully through this session, which will take approximately about 30 minutes or 40 minutes, you'll actually learn something about the solar system. Oh, well, on the other hand, the interest group here is CCK is called the universe. We are not talking about the universe. We're talking about the solar system today. All right. So a bit of a self introduction. I'm Clarence, the host today, and I'm actually a research assistant currently at the Center for Quantum Technologies, NUS, whereby I'm doing quantum cryptography, and I'm working on my master's as well as a part-time student at the NUS. I'll finish my bachelor's of science with honors in physics at the NUS. And previously, I was actually the president. I was part of the committee at the NUS Astronomy Society back in 2014 to 2018. Right. So and ever since I've graduated, I've actually took some time to this and I decided that I want to start an interest group for my neighborhood. So as you can see, the intention for starting this interest group is to bring the universe, to bring awareness about the science itself, as well as the art of astronomy to the neighborhood, right? And then, of course, together with me, I have my co-host today, Nicholas. Nicholas, would you like to introduce yourself?
Well, Clarence. Hi guys, I'm Nicholas, and I'm not so much a high flyer like Mr. Liu over here, but nonetheless, it's my pleasure to be here today as your co-host. So, I'm Nicholas, and I'm an undergraduate at NUS right now. I'm pursuing a bachelor's in mechanical engineering, aeronautical, and I'm the current logistics director of NUS Astronomical Society. So the 23rd Exco and assistant head question master for 2021. So as you can probably tell, I tried to dig out every qualification so that this slide isn't empty, but I couldn't get out much, so I just increased the size of my picture to take up more space. But let's get on with the actual show, shall we? Enough of introductions.
Maybe before we start, Nicholas, I'm just curious, right? So why did you decide to join the NUS Astronomical Society?
Oh, basically, I'm very passionate in astronomy. That's a generic thing everyone tells everyone.
Yeah.
But yeah, I've heard that it's a very fun, a very welcome and friendly club. So the interaction between its members is very wholesome as well. So it's a nice place for people to share their interest in astronomy. And that's pretty much why I joined.
Right, that sounds nice. So yeah, I guess that's pretty much why most of us are here today, including the audience who I can't see sadly. Yeah, and then today we're going to start. No, okay, so the solar system, right? So first, of course, Nicholas, do you know? Have you heard of the? Sorry, do you know what or who is in the solar system?
Well, I know there's at least the major planets.
Okay, so how many planets do we have actually?
Used to be 9, but
Okay.
one got kicked out recently.
Recently, yeah, of course. I believe we're talking about Pluto, and it has been demoted, I guess, to no longer being a planet in the recent times, the last 5 or so years. So, yeah, so the ancient Greeks were the first observers of the sky who actually noticed these objects in the night sky called planets, which they foresaw as wandering stars. So what happens is that in the night sky, they saw these objects that did not move significantly against the background of stars. Or rather, they move significantly against the background of stars. Hence, they call them wandering stars, and why it's called planets. And today, as of today, according to the International Astronomical Union, we recognize a total of 8 major planets, 213 natural satellites or moons. We have also other objects in the solar system, including the asteroid belt, comets, Kuiper belt objects, and trans-Neptunian objects, which actually includes Pluto today. All right. So Pluto, having been demoted, is actually now a dwarf planet. Okay. So we're not going to detail why Pluto is no longer a planet. It itself is an interesting topic, but we'll go on to the next part of what we are talking about today, which is then how do we remember the various order of the planets. So here we have essentially on the left, right? On the left, you see, if you read it downwards, right? My very efficient mother just served us nachos. So it's actually a mnemonic. Okay, a mnemonic is a term for whereby one can use a sentence to help you remember a sequence of or remember certain things, a sequence of objects in this case. So we're going to use this mnemonic, this sentence, to help us remember the sequence of the planets in increasing distance away from the sun. Okay, so perhaps Nicholas, have you heard of this mnemonic before today?
Oh yes, definitely. I've heard of this one before, and I really like it because nachos is one of my favorite foods.
Really? Okay, no, that's good. What about from the audience? Anyone from the audience have actually had a similar, known of a similar mnemonic, or how do they usually remember planets, the sequence of planets? Maybe Nicholas, you can help me out. I'll point out to any audience from the floor who might be able to see it.
Oh sure. Why don't we get our current president to point out a mnemonic?
Sure. Yes. Hi, Kaiwen. Or is that? I mean, it doesn't have to be mnemonic for planets, or in this case, right? Or maybe we can make it just. Is there a particular mnemonic you used to
The
familiar
mnemonic
with?
that came to mind was my very efficient memory just summed up nothing.
Something. Oh, okay. So yeah, so for various people, this mnemonic may come in different purposes to help you remember this sequence of planets in increasing order away from the sun. So today we're just going to introduce one particular. Of course, Kaiwen has mentioned a different one just now. So mine refers to Mercury in this case, very, Venus, efficient, Earth, Mother, Mars, just, Jupiter, Surf, Saturn, us, Uranus, not your fill in the blank, and Nachos for Neptune. All right. So before Pluto was actually demoted, I used to hear a different mnemonic. I'm not sure whether it's familiar with Nicholas as well. I used to remember it as my very efficient mother just served us 9 pizzas. But of course, I wouldn't be able to finish 9 pizzas. I'm not sure whether Nicholas or you could do that. Maybe with the audience with you, I understand there's about 20 of you here today. Maybe you'll be able to finish 9 pizzas.
Yeah, perhaps.
Yeah. Right. So of course, on top of that, as you can see from the slide, we can actually designate, right? You can actually categorize planets as inner planets and outer planets. So for when we say inner planets, we're taking reference to Earth. In this case, we have Mercury and Venus being the inner planets, meaning to say they orbit closer to the Sun as compared to Earth. While on the other hand, we have Mars, Jupiter, Saturn, Uranus, and Neptune being classified as outer planets. So meaning say they orbit at a distance further away from the Sun with reference to Earth. All right. So hopefully today, if you have not heard of a way to remember the planets, this will be helpful for you. Right, it's something that I always found it useful when engaging with young kids as well as during sidewalks. Okay, so here is a picture that I would like to introduce you to in terms of how what it means to be an inner planet. Okay, so not sure, Nicholas, have you actually noticed, right? Maybe how, or rather, maybe I just ask first, right? What time do you usually wake up in the day, in the morning?
That's an interesting question because time I wake up is probably past your lunchtime.
Past my lunchtime. Okay, that is very, very lucky of you. I guess this is a pre-COVID life as well in a way, right, Nicholas?
Thanks to COVID, yes.
Yeah. Or maybe you can look up for an audience member. Who actually will wake up at, I don't know, about 6 a.m. or 7 a.m. these days? Any of our NUS students actually do that these days?
Let me ask around. Anyone here wakes up at 6 a.m.? Oh, I see Ivy does.
Okay. Right. Yeah. So Ivy, maybe just ask you, right? Have you noticed, right, that there's this bright object in the morning, early morning skies at about 6, 7 a.m. in the day, right? That is near the sun. Have you ever noticed this?
She says she doesn't typically look at the sun.
Oh, okay. So perhaps after today, those early birds who wake up at 6 a.m., 7 a.m., you might want to take a look and see if you can find this bright star in inverted commas in the sky. So it will be, of course, in the early morning, it will be in the east. So if you look towards the east at about between 6 to 7 a.m., right, you might find bright stars again, once I say, objects in the night sky. So these are most likely possibly either Venus or Mercury. Or alternatively, maybe for most of us, which is might be easier, would be to look into the western sky at about similarly, but then 12 hours later, 6 to 7 p.m., you might see either Venus or Mercury as well. So these are the kind of the traits, right? The traits that an inner planet may have. So because of their relative position from Earth and our perspective of the sun, we would actually see Venus and Mercury close to the sun either before sunrise, right, or after sunset, or shortly in between a few hours, right? So it's something that maybe the members of public, the audience, you could keep a lookout in the next few days or in the coming months as well. Right, off the top of my head, I can't recall actually whether we can actually see Venus or Mercury right now. I don't wake up that early as well. Yeah. All right, next. So what exactly is the solar system? The solar system, of course, as I mentioned just now, who, right? But the question now is what. So the what here refers to how do we actually classify or define this this term. So the sun and the objects that are orbiting it directly or indirectly about the sun, as well as the comets and asteroids that we mentioned just earlier on, belong to this overall term, umbrella term, the solar system, right? And of course, this also includes the planets and their moons, dwarf planets as well. All right. Yeah. Next. So here we have a graphic that actually shows us the various objects in the solar system. So the nearest, of course, to the sun, you see Mercury, then Venus, Earth, so on and so forth. And you do just from this slide alone, you can see that Earth is one of the very few planets that actually has one moon. All right. If you look at Jupiter, it has 4 moons being shown here. Of course, there are actually other moons, as well as Saturn. That is not obvious here, but it has a number of moons as well. Maybe Nicholas, do you know how many moons are there in Saturn, or anyone from the audience can tell us that?
According to my memory, it's about more than 60, slightly.
More than 60. Anyone from the audience?
Let's see. How about you? How many moons do you think Saturn has? 61? 16. Okay, 16 moons.
Okay. Right. And then, of course, you have the asteroid belt over here. So we can say, okay, another thing we can see from this image alone is that Jupiter and Saturn appear very gigantic, right? So these are actually known as gas giants, okay, for a very simple reason. They are huge, hence giants, as well as they're actually made up of gases, right? While the planets like Mars, Earth, Venus, and Mercury, they are made out of solid rocks, right? Then next, we can see the later half. We see Uranus, Neptune. Similarly, they are also gas planets, much further away from the sun, and they themselves as well also have moons as well, right? They also have moons orbiting around the planet. Okay, so maybe we just stop for a while here, right? Jupiter's moons, right, they're highlighted here, actually do have a history to them. Okay, interesting story to them, which is that, or maybe before that, anyone from the audience might have heard of the story behind the 4 moons. No?
Well, anyone from the audience has heard the history behind the 4 moons?
Of Jupiter?
No? I see a lot of heads shaking.
Shaking? Okay. So these 4 moons are also otherwise known as the Galilean moons. So what happened here, right? Galileo Galilei was an ancient astronomer who first looked through the telescope, right, with his own very small 2-inch telescope, okay, roughly this size, right, 2 inches, and he actually looked towards the this planet Jupiter, and he saw 4 moons orbiting around it, and that was actually the first evidence, right, that we first evidence that we can infer that the planets and the sun does not revolve around the Earth, because we see moons, or rather other objects, revolving about a different planet, right? So that is the kind of the story behind the Galilean moons. So today, if you were to look through a telescope, not today specifically, but when Jupiter is up, right, you might be able to see through a telescope with a large enough field of view to see the 4 moons as well, revolving about it, right? And next, where is Earth, right? Sorry, this thing faded off. Where is Earth in the solar system, right? Earth, as seen before mentioned, is the third planet, from the sun, right? And this distance between the sun and Earth is known as 1 astronomical unit. Okay, so why do we want to use this distance and define it as one astronomical unit, right? Some may ask, is that we can actually use this distance as a standard to measure distances that are larger than they're further away from us, right? And on top of that, right, how to gain appreciation of how large this unit is, this distance is, it is roughly 4,000 times the circumference of the Earth, right? Can anybody tell me, maybe for the audience, what's the circumference of the Earth?
Anyone knows what's the circumference of the Earth? I see everyone's pretty silent.
Okay, so the circumference of the Earth is roughly, on if I'm mistaken, about 42,000 kilometers. So this distance between the Sun and Earth is 4,000 times of that. Okay, so means that if you were to go around the Earth in 80 days, you probably take 4,000 times that duration to be able to reach the Sun. Of course, that is just an estimation, right? And then we don't actually have cars or balloons to bring us around the world. That they can bring us to the Sun from Earth. All right, and on top of that, the Sun actually, the Earth actually lies in what is known as the habitable zone or the Goldilocks zone, whereby water, right, liquid water can be found, liquid H2O can be found, and life can actually be evolved, right, because of the temperature and distance away from the Sun, resulting in this temperature that is suitable for life to be developed.
Oh, but Clarence,
Yes.
do you know why it's called the Goldilocks zone?
Isn't that got to do with this nursery story that we used to hear about?
Oh yes, ever heard of the Goldilocks fairy tale? Basically, Goldilocks chooses between a set of 3 items, either rejecting the one that's too hot, too cold, too big, too small, and settling for the one that's just right. You kind of get where the scientists who named this zone are coming from now, right?
Yeah, of course. So the Earth is hence neither too hot nor too cold. Too hot meaning too close to the Sun, whereby then the temperatures in Mercury and Venus will be too hot for life, and too far, like the gas giants, whereby temperatures are really cold for life to be formed. And of course, maybe we can ask then, when and how was the solar system formed? So the solar system was formed roughly 4.6 billion years ago as a result of a contraction of gas and dust in this giant gas cloud floating in outer space. And this contraction of gas and dust from this gas cloud is a basis of this solar nebula hypothesis. Okay, so now maybe we'll take a look at some pictures, right, to see how we can find this evidence of this or inference of such a hypothesis. So here we have an image taken of the Trifid and Lagoon Nebula. How many from the audience or Nicholas yourself, have you seen this object before?
Through a telescope, no. Images, yes.
Okay, so this is definitely an object that that can be seen through a telescope faintly, even in Singapore, as such a light polluted country. So when we can see this object would be during the summer in Singapore, roughly between June-July periods. You'll be able to see it in the night sky easily, between from 8 p.m. onwards. So that's something that I guess the members of audience will be able to keep a lookout for in a few months' time. Right. So these two objects, Trifid actually refers to the object on the left here. If you can see my cursor. So Trifid means, if you break up the word, it's tri and fid. Tri referring to the 3 colors or three types of nebulas that you can see within the structure itself. The reflection nebula that is slightly bluish, the emission nebula that is reddish, as well as the dark nebula that you can see that is generally blackish in color. Okay, and of course, on the other hand, you have the Lagoon Nebula, which is this blob over here that's reddish, which is a emission nebula, right? But of course, today we're not talking about the nebula. We're looking at the hypothesis, right? The solar nebula hypothesis. So here, within this giant gas cloud, you can actually see a lot of blue stars here, right? Against a backdrop of very orangey stars. Nicholas, have you been, when we were young, right? Have you tried to touch the flame of touch a flame?
Oh yes, I did, and it wasn't a very pleasant experience. I'll give you that.
So, do you recall, right, which part of the flame was hottest? Was it the bluish part or the reddish part?
I'm pretty sure it's the bluish part.
Right.
Around
Okay.
this area, yeah.
Yeah. Okay. So we're gonna make use of this childhood memory or pain of flame, right, to draw the analogy of how we can tell from the colors of a star to know whether it is young or old. So a star that is bluish, as you can see, right, is generally younger stars as compared to the orangey stars. Why is that so? So drawing an analogy from the hotter flame or hotter flame that we may have touched once when we're young, the bluish flame is hotter and requires a larger amount of fuel, right? So the idea here is that if the bluish star is it has to be a young star because then it would not have run out of using its fuel. While in comparison, the older stars that are orangey have run out significantly of its fuel and hence does not burn as bright as hot as well as compared to the bluish star. And you can actually see a lot of them. These blue stars actually are found within this gas cloud that we see right over here in Lagoon Nebula. So we can say another way to put it is that these nebulas, right, these giant gas clouds in space are actually nurseries for young stars, whereby each of them could actually be a solar system, just like ours. Which is why a lot of modern astronomers find it interesting to ask questions of whether we're alone in the universe, right? But of course, that's a topic for another day on astrobiology, right? And next, these are just some close-up images of young stars and old stars, but of course they don't appear bluish. Mostly don't appear bluish here because of imaging in. This is image in infrared. This is image in visible. So they do appear blue, kind of whitish and bluish here, as compared to in this other image here. All right. And then here, okay, so we've come to the next part, which is an activity. Lucas, can I get your hand help out to check if everyone from the audience do they have a piece of paper with them, A4 piece of paper?
Okay, let me check right now. Everyone got a piece of paper? Yes? Okay, there's some here for those who don't have.
My God, it's the strangest NUSAS meeting I've ever had.
All right, we're handing out some papers now.
Mm-hmm. So I do not see any questions so far from the Facebook Live. For those who have just joined us, we are starting soon on the activity. And those on YouTube, Julian, any questions from YouTube? Or any questions at this point in time from the audience there at in NUS?
I see that most people are very enthusiastic about the activity.
Okay, that's good.
Okay, it appears almost everyone has the paper now.
Okay, so now I guess we can begin with this activity. So this activity is called the Pocket Solar System. So at the end of today, I hope that everyone will be able to appreciate the scale of the solar system and the distance, how the distance between the planets and the size of this solar system, right? So what you will get at the end of session will look something like this. Okay. So before we start, okay, we're just going to talk a bit about some of the values relevant to in respect of the solar system with reference to Earth. Okay, so we are Earthlings, right? So we should be familiar in a way to the mass of the Earth, right? So the sun is, as you can see from the table, is the largest object in the solar system. It makes up like 99.8% of the mass in the solar system, right? The planet is only accounting a miserable number of 0.2%. Okay, and diameter of the various objects as well. You can see the sun is roughly about 109 times in diameter larger than Earth, and the smallest here we can see would be the smallest planet we can see would be Mercury. Now that we have demoted Pluto, okay, and then we can see the order of distances as well here. So the furthest object being Pluto or Neptune, which is 30 astronomical units away from the sun. Okay. Now, so what we have here, of course, is the activity. And these are some symbols for the activities we want to just share with you today. And this activity likely should be carried out in pairs if you can. If not, if you wish to carry out this activity by yourself, that's fine as well. Especially for those who are watching this from home. If you have a piece of paper with you, you may do it by yourself. Instead of two pieces, one piece will actually be sufficient. And maybe ideally you have a piece of a marker pen with you for you to write, and some scissors as well as a roll of tape. Maybe that's something that Nicholas can keep a lookout for if anyone does not.
Oh, Clarence, it appears some of our members are quite curious as to how these symbols came about.
Right. Okay, so these symbols are generally Greek symbols, right? So they just represent the various planets, right? And of course, most familiar to the two symbols that are most familiar to us would of course be Venus and Mars. They're associated with gender, right? Mars the saying goes that males comes from Mars and the females come from Venus. Of course, that is just a saying. We are Earthlings. We do not come from other planets, right? And then, I mean, if I really do come from Mars, maybe I will have a different. I don't know. Maybe I have two heads. I don't know, right? Of course, I'm joking, right? I'm joking. All right. So next, okay. So at this point in time, if you have a tape, right, I would like you to tear a length of the tape. The length of tear the tape with a length roughly the length of the A4 size paper, and I would like you to paste it on the A4 size paper, dividing it by half along the width. All right, and when you guys are roughly done, maybe you can Nicholas can give me a thumbs up as well, or for an audience, you guys can give Nicholas a thumbs up when you're done, and then we can move on to next.
Yep, I see that they are trying to do what you told them to do.
Okay. Similarly, from those who are watching from Facebook or YouTube, hope you can follow the instructions here. If you have any questions, do just post them in the comments, and we will address them as soon as possible. This is a fairly simple activity that you can do from home, and you can actually do it in future if we have kids. You have kids, or for NUSA's case, if you like to, if you conduct a site walk for kids, this can definitely be an activity.
Okay, majority of them have pasted their tape.
Okay, great. So next, right, on the far left corner of the tape, strip of tape, I would like you to demarcate a line and label it as the sun. The midway mark, right, if you fold the paper in half, the midway mark will be where Uranus is, and on the far left end, that will be Pluto, right? That's your trans-Neptunian object. So as you can see, we're bounding the length of the tape as the reach of the Sun to Pluto and the distance itself. So every other planet will be compressed between this distance.
So they're just supposed to mark with a line, right? Not
Yeah,
a
they can mark
symbol
with a
yet?
line, and then of course below they can write down the symbol. I can flash back the symbol. If they like, they can indicate with a symbol as well. Well, we can go back to this, right? We can go back to this later on. You can mark out with a name first.
Okay, they appear to be more or less done marking out these.
Great. Next. So now we fold another half, right? So we should have a total of 4 sections here. So on the midway between the Sun and Uranus, there lies Saturn. You mark a line between them and label it Saturn, and the line between Uranus and Pluto, that is where Neptune is.
Okay, they appear
Right.
to have folded it. Okay. The markings are done.
All right. Next, the midway point between the Sun and Saturn, that is where Jupiter is. Right. So Jupiter, the gas giant, the largest. Right. And Saturn. Right. So Jupiter, the largest planet in the solar system, lies halfway between the Sun and Saturn. So as of this point in time, we've identified 4 planets. We have 4 more, and they will lie between they will lie between the Sun and Jupiter. And you can see that the space between between Sun and Jupiter is significantly much smaller than compared to the space between the Sun and Pluto. So a lot of the mass is actually concentrated, or rather, a lot of the planets are being concentrated within this very small area.
Okay, good to move on.
Okay, next, I'd like you to fold 3 creases between the Sun and Jupiter.
Oh, this part seems a little bit more complicated. So
Yeah.
folding is a bit more difficult.
No problem, we can take some time. Yeah, we want to make this a memorable experience, make it something that everyone will be proud to take home and actually show their friends and parents, of course. Once again, for those joining us on Facebook or on YouTube, this is Clarence, and I have with me Nicholas from NUS Astronomical Society. If you have any questions regarding the session, please leave a comment and let us know. We'll address them as soon as possible.
Okay, I think everyone's followed their 3 creases.
Nice. Okay. So next, on the first crease nearest to the sun lies Mars. Right. So I want you to mark it there. Not a joke. There's no kidding. Mark it there. That's where Mars is. And now we're left with 3 more planets.
Okay, marking's done.
Okay, so this is where it'll be good, valuable if your handwriting is small because it's gonna get very much exciting here, right? Next, so similarly mark out 3 creases between the Sun and Mars, labeling Mercury, Venus, and Earth respectively as shown. So
Oh, wow.
effectively, the last 3 planets of the solar system is packed within the very tight space between the Sun and Mars. So you can actually begin to notice the spacing between the various planets is actually getting larger and larger as we move further and further away from the sun. So much of this is empty as well, right? Of course, we have the asteroid belt, and the comets, right? But then, of course, all this actually a lot